a little bit about this. It was just interesting in 2019 and then last year when we had the floods. You can go out there and see it. This is at the Corrales Siphon sometime during the event, and you can see there's a lot of changes happening. And so this is a picture from 2019 about Los Lunas, the Highway 6 bridge, and you can see that there's the flow is everywhere. And there's an open area, and there's some places with denser cottonwoods and others with less dense. And I think some of the times the vegetation is easier to see, but that river is not moving water at the same speed. Some places are faster, some places are not so fast. And the sediment that's at the bottom is not moving in the same way either. So the sediment that's in the faster streams ends up being a little bit coarser than the sediment that moves into the floodplains. And so here's just an example. In 2019, there was a collaboration between the Corps and Bureau of Reclamation and the USGS. And we did some sediment measurements around Central. And this is just looking at the bed material samples that the USGS did across the cross-section. You can see the green pluses are coarse sand that was about the median bed material size when we looked at gradations. The diamonds are medium sand, and then you have one area that must have been moving a little bit faster that had very coarse sand. So that when you go across the cross-section, it's not the same type of material that ends up on the bed. So this, I started thinking about this when 2019 that, okay, well, if our current channels don't have the same type of bed material across the cross-section, what about all the old channels? And so this is a picture of the Albuquerque area, or a portion of it, in 1918. And you can see there's I don't know if the pen, does a marker work? Oh, there it goes. You can see this here is active channel, and then there's brush and bosque on each side. But the flow kind of moves around these islands and comes down. So I would expect, if it's like the rivers now, that you had some sections that had a lot coarser material and others had silts and fines. But the issue with this is, and you can see it, this word alkali is, and UNM has a bunch of reports, or at least a couple of them, of historical data, and they're very interesting. So this shows a picture around the 30s of the Corrales area and the issues they were dealing with in the valley because everything was flooded and they couldn't grow crops. And so they decided they were going to do something about that. And so one of the things that they did was they built these structures across all these channels and say, hey, we really think it would be better if we could just get the river in one place and move it down. And so they blocked these off. But you can imagine before they blocked it off, these might have been sand or coarser stuff, and after they blocked them off, and they blocked them off with a bunch of brush, and then they weighted it down with concrete. Some of them, and I still see a few of them out there, they did anchors, and then they had this woven wire mesh that they used. So they closed off a lot of these side channels. Well, when you close it off, now the flow is not so high, and you're starting to deposit silts and clays. So when you go out in the bosque, in the overbank, you see a lot of areas that are silts and clays, and you only see the sand portions in the river, but there's still remnant old channels below all of that have coarser material. And so thinking about that, we came up with this hypothesis that what if those old channels, and here you can see the red is the 1918 active channel, and this blue is the 1935. We also looked at 1949, but it's even less than the 1935. But you can see that there's some areas that go outside of it. And though I have circled those there. And so we thought, well, what happens when they came in and they just excavated the ditch? So they excavated a drainage ditch, and they just put that material up here. When they excavated, the hypothesis was that, hey, when they cut these off, it might have been coarser material. And so now you have coarser material that's at the toes of these structures. And if you have a big flow, then that may have more permeability through there and cause issues. And so the reason, before I move on, so just throughout the rest of the talk, when I talk about the active channel, it's just this section in here that doesn't have any vegetation on it. So it can be open water, it can be bars that have no vegetation. And then you have the left and the overbank when you're looking downstream, and all of that between the levees we'll call the floodways. But then there's these drains on either side of it. And so in 2019, an interesting thing that happened was we put a map together, and the MRGCD and the Corps and the Reclamation and a bunch of others made points where there were issues. And so we have these issue locations, and I went through that database and said, hey, I'm really only interested in areas where there's actually seepage, like you can see in this one, and then you get the bank to slough off. And so MRGCD came in and fixed them, but those are still areas that I'm interested in to see, is there a correlation with the old channels? So the hypothesis, one of them was that, hey, that those old channels did have coarser material, and when they connect with the spoil levee, they're going to cause problems for flood control because it gets more seepage, more sloughing. And so the hypothesis says, yeah, there probably is a correlation between issues that were noted in 2019 and active channel. But we also wanted to correlate and say, hey, do we actually see larger particles at those locations, at those issue locations? Are they bigger than other places? So those are the two questions we asked, but I mean, we're looking at it from a flood control perspective, but what does it matter for the collaborative program? And the thought was like, well, if these active channels actually, if the historical ones have a higher groundwater flow, that may be more beneficial to vegetation than just doing restoration anywhere. So maybe we can, if there is this connection and we can see it through flood control issues, then maybe other places where we have these historic channels may be viable restoration stuff if we're trying to get a larger groundwater flow through it. So how do you set it up? Because we didn't want to do any data collection. We wanted to say, hey, can we answer this with what we have? And so we have the active channels from 1918, 1935, 1949. So those are all digitized. So we use that. And the Army Corps has been collecting borings along the levee for several years. And so I compiled a bunch of the borings that we had in the area. Now we were only looking from Corrales Siphon down to the I-25 bridge. So I gathered all those borings, and those borings also, as they drill down, they tell us, hey, this is silty sand, this is sand, and they gave us gradation, and I was going to use that with then elevation. So we took the 2022 LiDAR that Reclamation collected, and so across the cross-section, I looked at that and said, okay, most of the borings that the Corps did are on this levee. So I'm going to call this top of the levee my base elevation, and I want to know what's the relative depth on either side of that levee. So the riverside toe and then the drain toe. And then I also want to know what's the depth between that top of the levee and where it hits the drain, which we think is probably the water surface, and then where it also hits the river. And so I used all those depths and correlated it to the levee height, because the borings, when they come out, they just sit and they say, hey, you're 2 feet below the surface. So it doesn't really help if I don't have an elevation. So I had to assume that, hey, well, I know they're on the levees. Most of the levees haven't changed since they did it. There's a few, like the Albuquerque West, that I had to do an elevation adjustment because they put in an engineering levee in between when we did some of the borings. So you have to adjust that, but then I can use the borings to identify, here's the soil type. From the gradation, this is the medium size. And so these are the gradations I use, and I classified it saying, hey, at this relative depth, what is the material? Is it very coarse sand, very fine sand? Is it fines? And I did that for all of these locations. And at those locations, when we're pulling these, extracting this, we had the boring that's here, and then we just went perpendicular to the flow of the water across to pick those locations on the active channel, the levee toe is the riverside toe, and then the drain. So I'm just going to show some of the findings we found. So this is showing at the issue locations that we found in 2019 where there was seepage and sloughing. The 1918 active channel, about 19% of those points were in the active channel of 1918. Most of them are in this bin 7, which is no data. They didn't map it for anything, which is of no help whatsoever. And the remaining was the 13 is vegetated islands. But then you move into 1935, and you see there's nothing of all those issue locations, none of them are in the active channel anymore. But 4, which I have to use my cheat sheet, is in what they labeled as flood prone, and then 8 is outside their study area. And so I was like, well, that's interesting. You have active channel, and then as through the years, you had stuff that's still, all those areas, most of them are still flood prone. And then when you get to 1949, most of them are in this, which is labeled now as upland area. So from the aerial photography, like there's no way this is getting flooded at all. And so even with just looking at the plan forms, you can see, well, there's a shift away from where these issue locations are. Like some of them were in the channel, some of them were close to the channel, or able to be flooded, to now they're upland areas. So you can see kind of, like when you look at the river now, it says, well, why is there seepage here? What's the issue? And the issue came maybe from in the past. So I see, like, for that last one, that there is some of the areas are correlated to an active channel. So I looked at the sediment stuff, and that wasn't too promising. So the median, which is here, when you look at most of the stuff across the cross-section, it's fine sand across all of them, so there's nothing really that differentiates. But on the D16, which I usually take as a standard deviation from the median, and you look at the riverside drain, and it's coarser than everywhere else that we put elevation data. And I said, well, that's interesting, because that's an area you don't want to be coarser. You don't want to have more water be able to move through it. We also did some testing of the data. So when you're looking at data sets, we have this sample, and I wanted to see, well, usually when we do this with hydrology, we're looking to see if we have an independent data set, and we plot them. And we can do it as a lag plot or a run sequence plot. This top one is a run sequence where I ordered them from north to south on the sites. So this 0 is the northern site, and then towards the I-25 bridge is down here. And if they're completely independent and there's no correlation, they should be all scattered all over the place, but they aren't. And it was interesting to me, because I was like, well, that's a very meandering pattern. And I was like, well, but we are going from north to south along the Rio Grande, so I was like, well, that's really interesting. So then on the lag plots, you have the first one, and then you plot against the active channel distance to the next one. And again, you hope to see just a scat shot, and there's no pattern, but you see that it's not quite well correlated. They all won't line up here, but there is some correlation, which made me think, okay, well, there is some correlation then between these active channels and those issue locations. So in the answer to the first question, I said, yes, there is some, but it's not like clear. It's not like, yes, all of the sites lined up. So there's some complexity in there that we're not capturing that. When we looked at the data, most of the sites were within 75 feet or less of an active channel in 1918, but there's a few that are like 1,000 feet away, so they're kind of weird. I left them in, I didn't take them out. The plots indicate there's some sort of level of correlation, but when we look at the boreholes to it, they don't have necessarily the same statistical analysis. And some of that is because we have issue locations, and I had to get the sediment from the boreholes, and sometimes they were right next to each other, and sometimes they're 50 feet, 100 feet, 500 feet. And so that, I think, kind of throws off some of the correlations. And then just to look at the second question of their larger particle size, this is down south, and you can see so that these red diamonds are the actual issue locations, and they're overlaid with a black circle if the river, at the river elevation, had coarse material from the boring logs. And they have a blue plus if the drain had a coarse material. And you can see there's some stuff, and they had a lot of issues here that, yeah, it looks like there's a lot of coarser material in there that represents an old channel that kind of went into that. But then there's other areas that, well, I don't know. I don't have anything that didn't show up for that. So possibly, and there's better ways to look at groundwater. If we had more data, a lot of groundwater wells, we could look at that. But it may have to do with some of the morphology, like looking at the outside of the bend rather than inside of the bend, and see if that matters. And then if you can get boreholes closer, that may make it a little bit less statistically spread out there. So, and with that, I don't know if there's time for questions or not, but I'll take some if there is.